Okay folks, today we're going to do naming on a compound. Specifically, we are focusing on the transition metals. So as you look at your ion chart, which you better pull out, you're going to need it, we're focused 100% on the transition metals. Now, we're not going to worry about your polyatomic ions right now. We're only focused on the positive transition metals, the things in the D block and potentially the F block, but the D block is what we tend to look at. Okay? So make sure you get that out before you go any further. Alright. So now, to be able to name these things, we need to figure out what kind of charges we have. So I'll do a couple, and then I'm going to start abbreviating because I don't want to sit here and write forever and just draw this out forever. All right. Clearly we have nickel and we have chlorine. All right. So when I do this, I will write this down as nickel, and chlorine obviously is chloride because it is the it's on the periodic table, so it ends in IDE, and it's an anion. The question is, do we put a number in here? So you pull out your ion chart, and you'll notice that we have nickel 2, but we also have nickel 3. So the question is, which one is it? Well, when you do your crisscross method in reverse, the 2 is going to come up here, and the implied 1 behind the nickel is going to come up here. So you'll say, well, this has a 2 plus charge, and chlorine has a 1 minus charge. Now what we're going to do every single time, and you're going to say this is stupid, but you'll appreciate it later, is you always check the charge on your anion to make sure it makes sense. It doesn't make sense that chlorine will take on a 1 minus charge. Yes, it does. So that means this is the correct charge for nickel, so it's a 2 plus. So you're going to put 2 inside parentheses here to be nickel 2 chloride. Similarly, we would look at this one down here, and this again is nickel chloride. But nickel takes on multiple charges. It does take on a plus 2 as well as a plus 3. When you look up here, this becomes a 3 plus charge, and this becomes a 1 minus charge for chlorine. Does it make sense chlorine takes on a 1 minus charge? It does. So the plus 3 charge for nickel makes sense. So this is going to be nickel 3 chloride. When you look at your ion chart, you'll notice there is a nickel 2 and nickel 3. Alright, how about this one? A lot of students mistake this for copper. It's not copper, it's cobalt. Right, cobalt, and this is cobalt, and this looks like it's going to take on a 2 plus charge, and chlorine is going to take on a 1 minus when I do my crisscross method in reverse. And does it make sense chlorine takes on a 1 minus? It sure does. So that means cobalt takes on a 2 plus, so this is cobalt 2 chloride. Alright, so here we have Cr and we have nitrogen, so that's chromium. And this is nitride. Now, does chromium take on multiple charges? Yes, it does. And my numbers here would crisscross, and it looks like I should have a 1 plus, and it looks like I should have a 1 minus. Right? Well, just looking at that, does nitrogen take on a 1 minus charge? No, never. It takes on a 3 minus charge. So that means chromium would take on a 3 plus charge. Does it make sense chromium would take on a 3 plus charge? Yes. So it would be chromium 3 nitride. Alright, now how about this one? Right? Well, when I do my crisscross, oxygen takes on a 2 minus, chromium takes on a 3 plus. Does it make sense oxygen is going to take on a 2 minus? Yes, it does. So chromium is taking on a 3 plus. So this also is chromium 3, and this is going to be chromium 3 oxide. Alright, starting now I'm going to abbreviate. I'm not going to write the whole things down, but I want you to make sure that you're familiar with what's going on. We'll write this first one down. Right. When I look at silver, I believe on your ion chart does not have silver 1, it just says silver, because silver tends to take on a plus 1 charge. So we don't have to go and write silver 1, we would just write silver oxide. And again, this would be, if I do my crisscross method, this would be a minus 2 and this would be a plus 1, so that makes sense. Alright, when I do my reverse crisscross, it tells me iron should have a plus 3, chlorine should have a minus 1. Does it make sense? Yes, it does. The chlorine would have a minus 1, so this is going to be iron 3 chloride. How about this one? Well, the logic same applies. The same logic applies. You have a 2 plus for iron and a 1 minus for chlorine. Does that make sense? Sure. So this is iron 2 chloride. So they're different. How about this one? Well, this one tells you that mercury, a 1 to 1. Does it make sense that mercury takes on that oxygen takes on a 1 minus charge? And that's 1 plus? No, it does not. So I have to double this number to be 2 minus, which means I have to double that number to be 2 plus. So do I have a mercury 2 oxide? I do, so this would be mercury 2 oxide. How about this one? Cadmium and sulfur. Looks like it's a 1 to 1 relationship. Does sulfur take on a -1? Nope. It takes on a 2 minus charge. So I had to double that number, so I have to double the one on the opposite side to keep them balanced. So this is cadmium 2. And if I look at cadmium, cadmium only takes on a +2 charge, so I don't need to write cadmium 2. I can just write cadmium sulfide. Alright, how about this one? Alright, when I do my crisscross method, it says cadmium should be 2 plus, and phosphorus should be 3 minus. Does phosphorus take on a 3 minus charge? It does. So this is cadmium phosphide. How about this one? This is strange. This says 5 plus over here and 1 minus. Does it make sense that fluorine takes on a 1 minus charge? It does. So this antimony would be taking on a 5 plus. So this would be antimony 5. Really? Fluoride. And if you look on your ion chart, you will find antimony 5. So yes, it does take on a 5 plus charge. Right? If I crisscross these, I again have a 5 plus, and I have a 2 minus. Does that make sense? For oxygen, take on a 2 minus? Yep, that does. So this is antimony 5 oxide. How about this one? Manganese and sulfur. Well, this says this is a 1 minus, and that's a 2 plus. You'll be real tempted to say manganese. By the way, that's manganese, not magnesium. Manganese is number 25 on your periodic table. Be careful with that. Sulfur does not take on a 1 minus charge. It takes on a 2 minus charge, so I have to double that. That means I have to double the 2 plus to a 4 plus. So this is going to be manganese 4 sulfide. And you're going to have the same problem here when you crisscross. You're going to have a 1 minus charge for oxygen and a 2 plus charge for tin. That doesn't make sense for oxygen. You have to double that number to a 2 minus, which means you have to double this number to a 4 plus. So this becomes tin 4 oxide. Alright, let's go through some of these. These are a little bit easier going from the names to the formulas. Iron 2 bromide. This is going to be iron, and it's going to be bromide. That's good. That's iron. Fe is iron. Bromide is bromine, which is Br. I have iron 2, which tells me this is a 2 plus charge. Bromine, if I look it up on my periodic table, by now you should know it's a halogen. It's 1 minus. When I cross them, I need to have 2 bromines, so it's FeBr2. Copper 1 oxide is a 1 plus. Oxygen's a 2 minus. Copper is Cu. Oxygen or oxide is O. I crisscross them. I get Cu2O. Now I have copper 2 oxide. Copper is Cu. Oxygen is O. 2 minus and 2 plus, they cancel each other out, so CuO is correct for copper 2 oxide. Now folks, let me stop right there because these are very important. Very common that students will mess these up. They'll look at the first one and say it's copper 2. No, it's not, it's copper 1. Right? The 2 refers to the charge, so be careful about that. Zinc 2 iodide. I don't buy that, guys. Zinc 2, there shouldn't be a 2 after zinc. So let me take that out of there. Right? By the time you look at your chart, there will not be a zinc 2. It's just going to be zinc. Zinc takes on a 2 plus charge. Zinc is going to be Zn and iodine, and that's a 2 plus, and that's a 1 minus, so you crisscross them and it's ZnI2. How about lead 4 sulfide? Be careful with this one. Pb is lead. Sulfide is S. Pb takes on a 2 plus charge. Sorry, takes on a 4 plus charge. Let's try that again. Sulfur takes on a 2 minus charge. Well, notice that I have a relationship of 2 to 1. 4 to 2 or 2 to 1. So my relationship when I take these down, when I crisscross them, I have to have 2 sulfurs to 1 lead. So I'm going to have to put a PbS2. I reduce to my lowest whole number ratio. 4 to 2 is the same as 2 to 1, so you have to be conscious of that one. Alright, how about tin 2 nitride? Well, tin is SN. Try that again. SN. And nitride is N. And nitride is nitrogen, so it takes on a 3 minus, and tin takes on a 2 plus. That tells me it takes on a 2 plus. So when I crisscross them, I get SN3, N2. How about tin 4 nitride? Well, that's also SN, N, with a 3 minus and a 4 plus. They crisscross, and you get SN3, N4. How about gold 1 sulfide? Well, gold it doesn't react very much with many things, but that's a +1 and that's a -2, and that's AUS. But when I crisscross my numbers, I have to have 2 gold, so it's AU2S. How about arsenic 5 iodide? Arsenic. AS is arsenic. Iodide is iodine. 1 minus, 5 plus, 5 plus, yep, 5 plus. So it's ASI5. How about zirconium? Well, you're going to have to look that one up. Zirconium is ZR. But the beauty of this, even though it's not on your ion chart, it tells you it's a +4. So it doesn't have to be on your ion chart, because this tells you what you need to know. So zirconium, let me put zirconium down here. Zirconium fluoride, and that's a 4 plus, and fluorine's always a 1 minus. So I need to have 1 zirconium and 4 fluorines. So it's ZrF4. Alright, how about these? Scandium. Right? Well, scandium, it tells you it's 3. So again, even if it's not on your ion chart, it tells you it's a 3. And you have to just find scandium, which is SC, and nitrogen. And this is 3 minus, and this is 3 plus, so they cancel each other out, so it's just SCN. How about scandium bromide? Well, this is going to be SC, and it's going to be Br. And this has a 3 plus charge and a 1 minus charge, so I cross them and I get SCBr3. How about lead 4 oxide? Well, that's Pb, and that's O, and oxygen takes on a 2 minus charge, and this particular lead takes on a 4 plus charge. Well, when I look at my ratio of 4 to 2, remember that reduces to 2 to 1. So I'm going to put a 2 after the oxygen and a 1 after the lead, so I have to have a 2 down here. PbO2. How about cobalt 3 oxide? Well, cobalt is CO, oxygen is O, oxygen is 2 minus, cobalt is 3 plus. I crisscross them and I get CO2O3. And the last one on this page is cadmium nitride. Cadmium, when I look cadmium up, I believe that's a 2 plus. I'm actually checking it as well, just to be sure. Cadmium is a 2 plus. So cadmium has a 2 plus charge. Nitrogen has a 3 minus charge. So this is CD, N. And when I crisscross them, I get CD3, N2. Alright, on to my next couple. Write the names of these guys. Cesium and sulfur. Alright, well that would be cesium. Cesium. Wow. That's back on our that's back on the periodic table. Ooh, that was tricky. Cesium always has a +1 charge. So I don't have to mess with that at all. I don't have to worry about 2s and 3s and all that. It's just cesium. It's on the periodic table in column 1 or 2. So strontium. Strontium, bromide. Chromium. Ooh, that's not so nice. Chromium. Chromium, let's see. When I crisscross those, that's a 2 plus and a 1 minus. Chromium is in the is a transition metal, so clearly that's going to be chromium 2. So you just have to make sure there really is a chromium 2 there. CHROMIUM2, chromium 2. Chloride. Yes, the parentheses are required, so make sure you put them in. How about iron oxide? This is iron, and oxide. Iron is a transition metal, and you'll notice that oxygen has a 2+ charge. If you crisscross, you get 1 and 1. Oxygen is going to have a 2- charge, so iron has to have a 2+ charge to counteract it. So iron's going to be iron 2 oxide. Alright, how about these guys? Well, when I crisscross these, I get a 3+ and a 2-. Does it make sense? Oxygen takes on a 2-. It does. So this is going to be iron 3 oxide. How about these guys? 1 and 1. But oxygen doesn't take on a -1, it takes on a -2. So nickel has to take on a 2+ charge. So this is going to be nickel 2 oxide. How about this one? We saw this one before, and I said it was tricky. Be very careful with this one. When I come up and I crisscross, I get a 2- and I get a 1+. Does it make sense? Oxygen takes on a 2- charge. It does. So that means copper takes on a 1+. So this is copper. I'm actually going to write this one out. This is copper 1 oxide. And how about this one? This is not magnesium, folks. Remember, this is manganese, and this is manganese and sulfur. And it looks like 1 to 1, but remember, sulfur always takes on a 2- charge, so manganese has to take on a 2+ charge. So this is manganese 2 sulfide. Alright, let's do the last couple. Platinum 4 sulfide. Well, the beauty is, again, platinum, it tells you that it's a 4, so all you have to do is look up platinum on the periodic table and figure out what it is, and I think it's PT if I'm not mistaken. Platinum, yeah. So this is PT, and sulfur is S, and this takes on a 2- charge and a 4+ charge, so remember that's a 2-to-1 ratio. I cross them, and I get PTS2. How about silver bromide? Well, silver takes on a 1+, bromine takes on a 1-, so that's AgBr, and I don't need any subscripts. Copper phosphide, Cu, phosphide is P, copper is a 2+, phosphide's a 3-, it's on our periodic table, remember that, 3-. Right, so I crisscross them and I get Cu3, P2. How about chromium 3 iodide? Chromium is Cr, iodine is I, chromium is a 3+, iodine's a 1-, I crisscross them and I get Cr(I3). And I think this is my last set, so let's do cadmium. Cadmium is, again, look it up. It's on your ion chart, and cadmium, CD and F. Fluorine is a 1-, cadmium is a 2+, I cross them, I get CdF2. Iron 2 phosphide, 2+, 3-, this is Fe, and it's P, and I have crisscross them, and I get Fe3, P2. Cobalt 2 iodide, 2+, iodine is 1-, crisscross them, I get COI, and I have to have a 2 after the I because I crisscrossed them. And my final one on this page is Fe, iron, phosphide, P, 3+, 3-, they cancel each other out, FeP is good. Alright, if you have questions, come see me in class. I'll be more than happy to help you. See you then. Have a great day. Bye-bye.